So we are going to be graphing our exponential functions and also some of their inverses. I'm going to fill some of these out for you, and I'll attach this, and I would like you to fill out the rest. So as we get started here, I do also have my calculator up, and that will help us if we have any trouble finding any of these, but I think we can do most of them in our head. So I'm going to start with 3 times 2 to the x. So I'm first going to take 2 to the x power. So this is like, get the pen here. I'm gonna do maybe 2. No, I'm not writing at all because my pen's not working. All right, so 2 to the negative 2 is 1/4. And then 1/4 times 3 is 3/4. So that first box should say 3/4. Okay, I just changed the battery in my pen. Let's see if we can work. Nope, still nothing. 3/4. Okay, that's not supposed to be negative. So next one, I'm going to do -1. So 2 to the -1 is 1/2. So when I fill this in, I should get 3/2. Okay. When I go to the 0, remember any number to the 0 power is 1. So this will just be 3. 2 to the 1 is 2. 2 times 3 is 6. 2 squared is 4. 4 times 3 is 12. And the next one, 2 to the 3rd is 8. 8 times 3 is 24. So hopefully that you see a pattern. These are doubling when I move to the left and dividing in half when I move to the right. So what does this look like on your graph? Okay, on our graph, we have, I'm going to start at 1, 2, 3 here. Okay, my pen is still not working, so this isn't going super great for me. Then I'm going to go over 1 and up 6. And then I think the next one, 3, 12, 6, 7, 8, 9, 10, 11. Here we go. And then it's going to start getting so big that I won't be able to graph. And then as I go down, I have -1 is 1.5. And -2 is 3/4, and so on and so forth. You should notice, though, that if I keep picking numbers to the left, like -3, -4, I could never get this graph to equal 0. So doing my best here as I'm drawing with my finger instead of my pen. I'm going to come really close to 0, but never touch it, and hover along here. So what's the pattern? I'm going to say the word start. And I am talking about right here. We start at 3, and we double every time. Okay, and my end behavior, as I move to the left, so that is as, oops, that doesn't work. Just going to give myself a little more room. As x goes to -infinity, our y's get closer and closer to 0. And as x goes to, I'm out of room, positive infinity, our y's get closer and closer to positive infinity. I got my pen to work, so I'm feeling much better now. And I'm going to do another one for you. So the first one is going to be 4 to the 2, which is 1/4 squared. Oh, man. So that's 1/8 times 1/2. So if you want to use your calculator for this one, we could do that. I have, let's see, 0.5 times 4 to the -2. And remember, you can go math, fraction. If you're on this, Desmos will give you something too. 1/32. Back to here, 1. And my pen is back to not working. Okay, if I go to the -1, let's type the same thing in again. Oops, that's not what I wanted to do. Just type it in again. 0.5 times 4 to the -1. and math fraction. We get 1/8. Okay, here I'll get 1/2 because 0.5 is the same as 1/2. Okay, 1/2 times 4 is 2. And 4 squared is 16. Half of 16 is 8. And 4 to the third power times 1/2, we get 32. Okay, you should try to graph this one. I'm not going to do that, but the pattern, we could say it starts again. Can't read any of this. Starts at 1/2, and then it times by 4. So then you multiply by 4. This is not showing up at all. Okay, right? Because I start here at 1/2, and to get to 2, I times by 4. 4 times 4 times. If I go this way, I divide by 4, divide by 4, divide by 4. This end behavior is going to look really similar to this end behavior. Try again here. So I have these 1 and 2 filled out. I would like you, these all say 2, so fill out the next 2 and the next 2. And then I will fill out some more of these. So you should fill out, I have 1 and 2. You technically are going to fill out 3 and 4. And do those on your own. Okay, what about this? So what about these that have, I'm doing the exponent here. So like this is 1/5. This one would be like 1/5. 1/5 to the -2. Every time I try to write on this, my pen stops working, and it works for a while, and then it quits. There we go. We get back to it. All right. So 1/5 to the -2 would be 25. And if you don't believe me, you can type this in your calculator. This was going to be 5. We're back to not work. There we go. 5. This will be 1. This will be 1/5, 1/25, and 1/125. Okay, so notice now instead of getting bigger, this one's getting smaller. This one is dividing by 5. So if I describe the pattern, I start at 1 and I divide by 5. So what happens this time is I'm at -2, 25 way up there, -1, positive 1, 2, 3, 4, 5, 0, 1, and then I start getting really close to 0 and I can't graph it. Okay, this one's like the opposite. As x goes to -infinity, our y's go to positive infinity. But as x goes towards positive infinity, our y is now getting smaller and smaller and getting closer to 0. But I can never get actually to 0. Okay, no matter what exponent I plug in, I cannot make that number go to 0. For 5 to the x, this would be 1/25. Again, my pen's not working. Okay, there we go. 1/25, 1/5, 1, 5, 25, 1/25. I hope you see the similarity in these. One is getting 5 times bigger, one is getting 5 times smaller. This one is the same. It starts at 1, but I multiply by 5. Okay, because like times 5 times 5. So this graph is going to look the opposite, where I start really small. I'm going to cross at 0, 1 still. Right here, this is my y-intercept. That was the same here, but it's going to get bigger and bigger. And so these are going to look a lot like these from up here, okay, where I started small and got bigger, bigger, bigger. So all of these equations are of the form y equals a times b to the x. If you do not have all the graphs graphed, you should pause now and go back there. Where does a show up on the graph? Well, when I'm looking at these, this is a, and this is a, okay? Notice it's also here. Okay, I'll circle with yellow then. Here we go. It's here. Didn't change my color. And it's here. And when I look down here, it's the same thing. So you should be looking at these. I guarantee that this number here is 10. You should have that done. This number here is 6. Okay? Again, this doesn't have anything in front of it, so it's like y equals 1 times 1/5 to the x. So this is the a here and here. So where does a show up? Okay. A, come on. A is the y-intercept, or where it starts. And what I mean by where it starts is it shows up in the table. A equals y-intercept. My pen stopped working again. And in my table, I'm going to just draw a quick table. A is always right here under 0. Okay. What does B tell you about the graph? Let's go up to these. This time I said I started and then I doubled. Notice right here, I am doubling. I said I started at 1/2 and multiplied by 4. I am multiplying by 4. I bet if you looked at this one, you'd be getting multiplying by 1/2, which is like the same as dividing by 2, and multiplying by 2/3 in that case. Okay, here I'm I'm dividing by 1/5. I'm multiplying by 5. So what does B tell you about the graph? If it gets bigger or smaller? Like this. Bigger, I multiplied by 5. So for example, my pen is working and then not working. Multiply by 5. Come on, pen. Okay, how did it get smaller? We multiplied by 1/2. We multiplied by 1/5. Something like that. We multiplied by 2/3. Okay, so can you tell from the equation whether the graph will increase or decrease on the entire domain? The ones that are increasing are the ones that we're multiplying by 5, multiplying by 4, multiplying by 2. Those are numbers bigger than 1. The ones that were decreasing were numbers like 1/5, 1/2, 2/3. Those are numbers bigger than 0, but less than 1. And is there an asymptote on each graph? Yes, there is. The graph has an asymptote, and the asymptote was always y equals 0. We can never make them equal 0. Okay? So it said, recall that if a point AB is on a function, then BA is on the inverse. Okay? So y equals 2 to the x. I already know that this is of the form y equals a times b to the x. And since I know I'm going to start at 1, because that's a is 1, and then I'm going to double 2, 4, 8. And going this way, I'm just going to keep dividing. Instead of doubling, I'm dividing by 2. Easy way to fill this out. Okay, so if I graphed this, I would have 0, 1, 1, 2, 4, 8, and then these would be getting, respectively smaller. My domain on here is all real numbers. I can put any number in, but for my range, my y's are always going to be not even greater than or equal to greater than 0. I can never make this equal 0, so it will always hug that. So for my inverse, remember when we did these, we just kind of switched our x's and y's. So my y's are going to be -2, -1, 0, 1, 2, and 3, and then I'm going to copy these. 1/4, 1/2, 1, 2, 4, and 8. And so -2, 1/4, -1, oh, I'm sorry, 1/4, and then -2. So let's see if I can make this work. 1/2, -1, 1, 0, 2, 1, 4, 2, like that. So this one goes like this. Okay, so notice this time my asymptote is like right here. It stopped being the line y equals 0, and now it's this line x equals 0, and I always hug that. So can I put anything in anymore? No, you will notice that I have no negative x's. I never crossed this line. This time my domain is x is greater than 0. But can I get any number out? Yeah, I can get numbers up and numbers down. You can see I keep going down, down, down. So these have switched. The inverses have switched. You should do on your own number 8, 9, and 10. Okay, so being able to graph an exponential function and its inverse is what you are trying to do. You may use Desmos as well to help you with these. Okay, so be able to finish any of these that I did not fill out.